3 and 1, yeah. Sum is 4. Difference is 2. How'd you get that?
3 plus 1 is 4, 3 minus 1 is 2. Wow.
Where'd you get the 3 and the 1 from?
Just going through like 2 plus 2, but 2 minus 2.
Possibilities, right? You just evaluated different possibilities and saw what made sense. Yeah. Right. You could say guess and check. I think it's kind of like oversimplification. But you had a rationale behind why you chose those numbers. You know, you probably wouldn't default to negative numbers or fractions or decimals or things like that, but it said 2 numbers. That's intimidating because it didn't say 2 integers, 2 whole numbers. It is allowing for any 2 possible numbers. It is conceivable that the answer could have been 2/3 and negative 7/8. Are you coming up with that as easily? Probably not.
Is that an answer?
No.
Is this the only possible answer?
This, I believe, is the only possible answer. And we're actually going to flesh that out algebraically in a second. But that's my point, is that we need another method because guess and check isn't always going to cut it. All right? Now, the phrasing of the second question is a little iffy. But I can't think of a different way of phrasing it without just flat out giving it away. Given that y is greater than x, write 2 linear equations using x and y to express this situation from above. It's Common Core language. Yeah. No. Yeah, right. Let me define the variables. Let y equal the larger number and x equal the smaller. That addresses this part because we just finished the unit on inequalities, so your tendency might be to say y greater than x. I mean, you can note that if you want, but this is really what that little phrase is getting after. Now that I know that, can I come up with the expression?
Could you do it as an inequality?
Normally I'd say
x equals 4 is equal to y minus x equals 2.
So that I'll take, but not the inequality part. So you have the right idea. Since it's specifically asking for linear equations, they have to have equal signs in it. All right?
Wait, but didn't that have an equal sign in it?
What's that?
Just 2 equals.
2 equals, that's all we need. So we don't need an inequality. But you got it, so that's good. Now the question becomes, well, what do we do with this?
Could you do y plus 4? Could you do y?
There's another way to express it if you wanted to do something like y minus 4 equals x. You know, just kind of moving some things around. But in order to merge it into one expression, we have to do some substitution. But that's a different story for a different day, specifically tomorrow.
It would be equal to negative x, right?
It would be negative x plus 4, yeah. If I added the, or if I subtracted the x from both sides. But we'll cross that bridge down the line.
Oh, you got to put in y equals x.
That's what we're going to do. So system of equations, by definition, I mean, well.
Oh, so you're going to subtract the y.
Well, we're going to leave the y's where they are. They're fine. But let's just define system of equations first. And first, it's really just multiple equations. I'm just kind of streamlining it a little bit. Multiple equations with multiple variables. And there's some conditions that come into play with that, but this is the essence of it.
Wait, just to not do that, but instead of the homework last night, I subtracted y every single time you go on the other side. Can you do that?
Did y eventually end up being alone?
Yeah, I just divided by -1.
That's fine. Yeah. Okay, multiple equations with multiple variables. I mean, it's possible. I gotta look at the curriculum again. Sometimes we cover 3 equations with 3 variables, and sometimes we don't. I just gotta see what we've kind of decided for this year. Typically, I mean, at least at this level, we start off with 2 equations with 2 variables. If I have 1 equation with 2 variables, I can't figure out anything in terms of what x is or what y is. But if I have 2 equations with 2 variables, I can. If there is a solution, I can get it. All right, and so that's kind of what we're working towards. All right, so using the 2 linear equations you created from question tool, graph each equation on the coordinate plane provided. So we had y plus x equals 4 and y minus x equals 2. We want to get it into y equals mx plus b form, also known as the slope-intercept form. All right, that's where we're going to start. That's probably what you learned in previous years. I don't know if you learned point-slope form for a linear function. You have? That's standard form. That's also good, and we'll actually touch on that.
No. Oh, it's point form the one where it's like x and y are on the same side.
x1 minus y1 equals m.
No, that's
x2
slope.
minus
That's how you find
That's
slope.
That's very close.
It's something like
It is. I'll just make a note here, because why not have it in the videos? So we have the point, or the slope-intercept. Which is y equals mx plus b. Depending on the textbook, sometimes they use ax plus b. It's frustrating. Everybody's got a different take on it. The m represents the what?
slope.
And the b represents the? Okay, very good. Then we have the standard form. Oopsie daisies. Which is the least common one. So why is it called standard? Yeah, I know.
That's what I was thinking of.
That's your standard form. It actually has a, it does have some value, and we will see the value of this particular form of a linear equation. It's just only in particular circumstances, all right? At least in this type of course. And then we have the point-slope form, which I think is the most useful one. Y equals m times x minus x sub 1 plus y sub 1.
We did.
You might have learned it as y minus y sub 1 on the left-hand side.
Oh, could you like flip them out or something?
That's the slope formula.
Can
That's
you,
also really good.
could you like switch out the ones you put inside of the parentheses? Can't you do like 2 x's? Can't you do 2 x's, 2 y's and an x? Instead of the x minus x1, can't you do y minus y1 plus?
I remember it being different from that.
Yeah, it's normally written as y minus y1 on the left-hand side equals m times x minus x1.
Yeah, that's how I remember.
Yeah.
But that's completely, utterly useless. Like, why the y minus y1 on the left-hand side? Like, what is the
You could
purpose
just
of that?
have it added on one of the other side.
Yeah, it's just so much nicer this way. This is calculator ready. And besides, this is gonna, when we learn about other types of functions, like curved functions, this is gonna match up with those very nicely. So this is the way you wanna learn it. Yeah. So the x1 and y1 are just some point that lives on the line, with the m being the slope. Before too long, we will have completely moved away from the slope-intercept form, and we will be living in the world of the point-slope form. And you'll be grateful for that. You just maybe don't know it yet. There's a lot of things that you just have to believe me about. I wouldn't lie to you. I'll tell you that. All right. So for the first one, I want to get y alone, so let me subtract off the x. For the second one, I also want to get y alone, so let me add the x. I want to write it generally, I mean, it's up to you, but I want to write it so that the variable part comes first. So it's in that nice y equals mx plus b form, so that I can easily identify what the slope and y-intercept are. So y equals mx plus b, again, is the model. So here we have an understood -1. Here we have an understood +1. So I know what the slopes are. And I have the y-intercept, so it should be pretty easy to graph. Okay. So, start graphing. Let me just get this out of the way. So, y equals -x plus, so 1, 2, 3, 4 units above the axis. And I'm gonna count off a slope of -1. A rise over run, -1 over 1, so down 1, right 1. I'll show you a little calculator trick after this too.
You have to fill out every single dot.
No, but since I'm gonna freehand draw this, the line, because I don't feel like trying to make a ruler happen here.
Button for a ruler?
There is, I just haven't figured out yet how to use it. Which one is it? Honestly, I can't even remember which one it is. Let's see. No, that's just adding like files and stuff. I think it's, I want to say it's this one, and then I hit that. Yeah, there's like a ruler. But what's the value of a ruler if it's always horizontal? Like I don't.
You could probably.
Oh, there it is. Okay. Oh, did it actually snap in?
I don't think so.
Oh, I felt like it did.
Oh,
It
it did.
did.
All right, now is it going to listen to me? Yeah, okay, fine. All right, you win. You win. Now how do I get rid of it?
Press it again.
Pressed it again.
Oh.
This kid is a genius.
No, you have to, press it's like a toggle, I think. So just press the ruler button. No?
Oh, just
Yeah.
gotcha. Oh, pencil? Oh, I don't want pencils. Oh, yeah. You know, my, all kidding aside, I do actually enjoy learning. So I'm actually feeling really good about this moment here. That is some solid stuff. All right, yeah. Oh, yeah. It's good news.
Bro, we used to have to label like the y equals -x plus 4 like on the line. We have to still do that. We can just label it like next to the line outside the graph.
Wait, you had to.
No, you were always allowed to do it like that.
I always like had to put it on the line.
You had to like write it like this.
Yeah.
Yeah.
Otherwise, you didn't get credit for that.
We did.
We weren't even told to label it. But Lazy like made us write it on the slope, or else we lose like a point off for it.
See, the only
She literally took 5 points off.
the only reason I'm even thinking about labeling it here is because I have two graphs on the same coordinate axis.
Oh, yeah, that.
If I only had one line, I wouldn't label anything.
Oh yeah,
All right, so then I hit ruler again, and there he is.
You can also adjust the thickness of it.
Let's not get too fancy.
Oh, but there's 2 different
Oh, of the curve.
thicknesses.
Oh yeah,
And it's weird. It's kind of obnoxious.
it is obnoxious. The more I look at it, the more aggravated I get. All right, so we have an intersection here at the coordinates of 1, 3, right? All right, so let's just talk about that for a second. So where is the solution represented on your graph? It's
Lines meet.
the intersection, or where the lines meet.
Actually,
Intersection at 1, 3. All right. Now, this may seem not necessary, but I'm going to do it anyway. When you're plotting points in space, because there's a misconception that I just need to make sure it doesn't carry forth beyond this moment, I guess. When you're plotting a point in space, that point, in this case 1, 3, what does the 1 represent?
X coordinate.
The what about the x?
How far to the right? How many units to the right it is?
How many units to the right it is from what?
From the origin.
From the,
Origin.
see, that's the thing.
You can say that. it
Yeah,
starts
from the
at-
y-axis. That's because what's happening is when you learn how to plot points, you learn to start at the origin and use this kind of as a recipe. Start at the origin, go to the right one, and go up 3. One second. So what I'm trying to get across is the idea that you're not always living on the x-axis. And so when I am really thinking about an x coordinate, I'm thinking about the distance from the y-axis. And when I'm thinking about a y coordinate, I'm thinking about the distance from the x-axis. All right, it's a subtle shift in thinking, but it's the kind of shift in thinking that makes a big difference down the line. Another thing that you have to just kind of trust me on. All right, so does it make any difference in terms of how you come up with your final answer? Of course not. But just knowing that any point in space is not really just limited to movement along the x-axis, it's just movement in general. That's an important thing to keep in mind. All right. Now, as far as how I represent my final answer, depending on how fancy you want to be, there's a few different options. You could say x equals 1 and y equals 3. So you're explicitly stating your answer. You can express it if it's a situation where you know that you're creating, I mean, like in this case, we're working on x, y axes. You have an answer that must be an ordered pair, x comma y. You can just simply state 1 comma 3. But if you want to get into some fancier notation like set builder notation, this is more appropriate for like algebraic solutions or solutions in which the variables aren't necessarily going to be x and y. You would say something like x and y such that the corresponding values are 1 and 3.
Isn't this more work?
Not more work, more writing. A little bit more writing, but here, this is more valuable when you're dealing with situations where it's not always assumed that it's x and y that you're working with. All right, so do you need to do this all the time? You hardly ever need to do it. Right? But if you have like a word problem, for example, and you let C equal the number of donuts Charlie bought and D equal the number of donuts that David bought,
It's not X,
then this might be a nicer way to write it. You know, so if you need a concise way of doing it. I leave it up to you as long as it's very clear and obvious what your final answer is.